All right, number 5 states to draw the graph of y equals 2x squared minus 16x plus 24, and we want to label its minimum. So each instructor somewhat teaches this a little different. So what we're going to do is trying to use like these generic steps. So the first thing that you like to do is find what we call the axis of symmetry, right? So the axis of symmetry is found by taking x equals negative b over 2a. So when you look at the quadratic function, it's written in the form of ax squared plus bx plus c. So you should recognize your values of a and b, right? In this problem, we're going to have the b be negative 16. So we have negative 16 over 2 times the value of a, which in this case is going to be 2, right? So our a value was 2. Our b value is going to be this negative 16. So when I plugged it into this formula, negative b over 2a, it's negative 16 over 2 times 2. 2 times 2 is 4. So negative 16 over 4 is negative 4. Okay, good. Now, oh, that's right. There's actually 2 negatives. My bad. I screwed that up. I'll fix it. Hold on. So it's negative of negative 16. You're right. Divided by 2 times 2. So this is 16 over 4, which is 4. Positive. This is what happens when you do math all day. I've been doing math since like 9 a.m. Okay. So we have x is equal to 4. Now what we're going to do is plug this into the function to get the y value for the vertex. So when x is equal to 4, y is going to equal to 2 times 4 squared minus 16 times 4 plus 24. So 4 squared is 32. No, 4 squared is 16, but 16 times 2 is 32. negative 16 times 4 is negative 64. And then you have the positive 24. If you work this out, 32 plus 24, you can take care of that first. That would be 56. 56 minus 64 is negative 8. So why did I solve for why did I solve for y here? It's because the vertex is in this form of negative b over 2a is always the x coordinate, which basically means that the axis of symmetry, that vertical line, always intersects the vertex at that coordinate, negative b over 2a. And if I plug in negative b over 2a into the function that we have, you always get the y coordinate. So for us, the vertex is going to be positive 4, comma, negative 8. All right. Now, we scale our axis. So we do the y-axis. We're going to do the x-axis. So I'm going to zoom in here. We plot the vertex. So the vertex is 4, negative 8. So I'm going to go 2, 4, 6, 8. I'm going to do negative 2, negative 4, negative 6, negative 8. So here is our vertex. Our vertex is a minimum because the fact that the value of a in this problem, by the way, was positive. So you know that the parabola makes like a U shape. Okay. Another thing that you could have done was you could have found the zeros for this function, or you could have plugged in, because of the axis of symmetry, you could have plugged in a value directly to its left and a value directly to its right, get some other value to get a couple of additional points, right? So observe. I could find the zeros, but I'm electing not to. I just want to see what happens when I plug in x equals 2 and x equals 6 into our function. if I plugged in x equals 2, that will be 2 times 2 squared, right? So y equals 2 times 2 squared minus 16 times 2 plus 24. So this will be 8, this will be 32, and this will be 24. So 8 plus 24 is 32. So 32 minus 32 is 0. So that actually worked. That is one of the intercepts. All right. If I plugged in x equals 6, I should also get 0, only because from the left, x equals 2 is exactly 2 units away from x equals 4. So if I was 2 units in the other direction, namely from 4 to 6 or 6 to 4, however you want to look at it, that's also 2 units away. So let's see. We have 2 times 6 squared minus 16 times 6 plus 24. So what is 6 squared? That's 36. 36 times 2 is 72. This will be negative 96 in the middle, and then 24. So 72 and 24 is 96. So 96 minus 96 is 0. So it also worked. All right. So we have our 3 points. You can connect them with make like a parabola. Unfortunately, my parabola is not going to come out nice because the scaling was terrible. Kind of. I didn't really scale my y-axis. I could have. Say that was positive 8. That would have been the y-intercept. Yeah, sorry about that, guys. You're not going to get a nice parabola there. It's hard for me to fit it in that right-hand corner of the screen. Okay, that's going to be our parabola. So that's number 5, right? So you get your axis of symmetry, you do the vertex, and then you label it, you plot it on the graph, and then you plot some additional points. Whether the additional points would have to be finding the zeros of the function, or you take the function, set it equal to 0, do it algebraically. That would probably require you to do some factoring methods or use the properties of symmetry. Okay. Anybody have any questions in the chat? Okay. So let's look at problem number 9 now. Problem number 9 says, okay, you're going to be given a graph of a parabola. And what you want to do is write out the equation of the parabola. This one's a little easier for us to work with, this problem. If you want to write out the equation of the parabola, you use the alternate form of the quadratic function, right? The alternate form for a quadratic function is y equals a times x minus h squared plus k. A tells you that, okay, if it's positive, the parabola opens upward. If a is negative, the parabola opens downward. And then h comma k is the vertex. So first thing is, when you look at your parabola, identify the coordinates for your vertex. What is my coordinates? That's right. The x value is -2, and the y value is 3. So we say -2, 3. So we get y equals a times x minus -2 squared plus 3. So x minus -2 is actually x plus 2. So this gives me y equals a times x plus 2 squared plus 3. Now, we would have almost been finished with this problem, but there's just one thing missing. The thing that's missing here is the value of a. To find the value of a, you need to choose another point and plug it in for your xy and solve for a. So can you give me a point on this graph that's relatively easy for me to use so that way I can solve for a? That's right. I can use the y-intercept, which is 0, -1. So this will give me -1 is equal to A times 0 plus 2 squared plus 3. All right, now you just got to solve for A. To solve for A here, we get -1 is equal to A times 0 plus 2, which is 2. 2 squared is 4. So I'm just going to rewrite this. All of this good stuff is just 4A plus 3. Then you subtract 3 on both sides. The 3's here are canceled. You get -4 is equal to 4A. Then you divide by 4 on both sides. We'll get A is equal to -1. So since A is equal to -1, I shouldn't say that's my final answer, but your final answer now would be y equals -1 times x plus 2 squared plus 3. And that's how you write the equation of the parabola. So this was problem number 9. Any questions? Okay. There's one more problem that requires you to know about quadratic functions, and that's the word problem. That is the number 16. So number 16 states, basically that vendor prices keychains at $5 each. She sells 210 keychains. For each $1 she raises the price, she sells 10 fewer keychains. What we want to do here is use an equation to determine what she should charge. I'm going to get there. To maximize her revenue from sales. Okay, so there's a little acronym that can help us for revenue problems. All you got to think about is these 3 letters, because in the alphabet they occur in succession, right? If you sing your alphabets, ABCs, you get PQR. So what P stands for is price, Q stands for quantity, and R stands for revenue. So in short, when you look at them in terms of functions, we say that the revenue function R of X is equal to P of X times Q of X, right? Revenue is equal to price times quantity. But again, just think of it as the acronym PQR. All right, what you need to do now for this problem is write out the linear equations that describes the price and the quantity function, right? So the revenue function R of X is equal to a price function times quantity function. The very first sentence of the word problem gives you your initial price and the initial quantity. So what was the initial price that she was selling the keychains? Yeah. The initial price was $5, right? And then she sells 210 keychains. That will be the initial quantity. Right? So these were your initial values. Initial price, initial quantity. Okay. So now the second sentence tells you how to write out now the linear equation. It says for each $1 she raises the price, she sells 10 fewer keychains. So when you see each $1 she raises the price, each $1 she raises. How can I rewrite that mathematically? We say plus because of the word raises. So 5 plus what? Think about that word each. Is she only going to be raising the price by just a single dollar or multiple dollars? Think about what that word each means. Do we have singular or multiple? It's going to be multiple. So it's not just $1, but it's going to be $1 every time that the price raises. So how would I write that mathematically? One what? Well, here's the deal. Do we know exactly how many times she raised the price? No, it's an unknown. So what do we use to describe an unknown in math? X, like a variable. So each $1 she raises the price, you can write it as plus 1x or just plus x. Okay. Now, because she raises the price by every dollar, she then sells 10 fewer keychains. So the quantity depends on the price, right? If the price is increasing, then you're going to sell less quantity. So how can I write the 10 fewer mathematically? Minus 10 what though? Minus 10x. Very good. Because every time that she raises this price by a dollar, you get 10 fewer keychains. So you say minus 10x. All right, so now that we have the price and the quantity function, you multiply it by expanding it together to formulate the revenue function. So I need to use the FOIL method. So you do 5 times 210 and 5 times 10x, negative 10x. So 5 times 210 is 1050. Then 5 times negative 10x is negative 50x. X times 210 will be positive 210x. And then lastly, x times negative 10x is negative 10x squared. When I rewrite my revenue function by combining like terms and writing it where the power is in descending order, you should get that the revenue function would read as negative 10x squared plus 160x plus 1050. Okay. All right, we got our revenue function. Now we're ready to solve. Now, when we look at maximum, trying to maximize our revenue from sales from the quadratic function, the maximum value should occur at what location? Anybody know? If you look at a quadratic, like let's say I drew a parabola. When you look at this quadratic function, by the way, will the parabola be a smiley face or a sad face? Meaning, would it go upward or downward? It'll go downward, right? That's right. So if you look at this parabola that I just drew on the side here, your maximum occurs at the vertex. And we know that the x value of that vertex is always negative b over 2a. So from the revenue function, solve for negative b divided by 2a, and you get some x value. That x value corresponds to the number of times that she has to raise the price. Okay, so x equals negative b over 2a is negative 160 divided by 2 times negative 10. But 2 times negative 10 is negative 20. So you get negative 160 divided by negative 20, which is now going to be 8. So this means that she has to raise the price by 8 times. Okay. Now, if you want to figure out the part where she says what she should charge, she's not asking you for what would be the maximum revenue now, but rather she's asking you what price she should charge. So since the price function, since P of X was equal to 5 plus X, then we need to solve for P of 8. Because I know 8 is the number of times where she has to raise the price. So when I plug that into the price function, you get 5 plus 8, which is 13. So she had to raise the price by basically, she had to raise the price to $13 in order to maximize her revenue. Okay.